Hello everyone. Let's take a look at improving our outputs again, this time specifically talking about numbers. Because if we do this, we just are going to divide this really big number by 3 and we run it, we're going to end up with this sort of ugly looking floating point number over here. And that might not be what we're interested in. So we're going to take a bunch of copies of this and we're going to try some different formats out and see what happens. So the format command is another function that we can use. And you'll notice when I popped it open, we actually get to see a little help right here that's going to walk us through what it needs to be. It's going to be the value followed by the format specification in single quotes. So there's our value, the calculation, and now we need to specify it. And the first thing is we want to say that it is a floating point number. So we're going to use f. And then we can say how many decimal places we want. So let's go with 0.2f. This will set it so that it's at 2 decimal places. So we'll chop most of this off. Okay? But we have a few other options. So let's take a look at a few of these other options and we'll see what they look like. So let's instead say, let's format this calculation. And we're going to format this calculation in exponential form. So we're just going to say format and we're going to say E, again in single quotes. And then we're also can specify it as well with a precision. So let's say this time we're going to say it is going to be 0.2E, for example. And let's see what that's going to look like. And last but not least, we can actually format it and we can specify whether or not, I guess not, there's two more things, excuse me. We can specify whether we want commas, because you notice I have no commas here. We don't really like commas every thousandths place and things like that. So let's look at that one. And then we'll do it one more time. And this time, we're going to put a number in front of the comma. I'll put 20. And this is going to show us how big the field has to be. So now let's look and see what we've got. This is going to look a little bit different. Oh, we got a typo. What do I have wrong? Oh, I missed some closing parentheses. So this is another classic error. Notice it's giving me the error on this line. When it gives you an error at the beginning of a line, chances are the actual error is the line above. And if we look, I opened 2 parentheses, but I only closed 1 at the end of the line. So you'll also notice when I close the parenthesis, it highlights the whole area that just got closed. So that's a super common error, and it's good to see and see the fix for it. So here we go. This is the initial calculation. Here's it cut down to 2 decimal places. Here's the normal exponential notation. Here's it chopped down to 2 decimal place scientific notation. This time we've got a comma in it, and now we've got this in this giant 20 space field. And you'll notice it slides it to the right. That's really useful because watch what happens if we grab this same calculation again. Let's just copy and paste it a couple more times. And this time, let's just type in some numbers in here to make our lives a little easier. 5.00 and 1,234. Whoops, I still have to format them, excuse me. So we'll just format them instead of the calculation, and we're just going to put them as 20 Fs, and put this one at 20 Fs as well. Let's see how this looks like. Run module. Is it okay? Oh, I forgot those extra parentheses again. As you can see, parentheses, super common errors. Let's take another look. All right, so this is what makes this really useful, right? So our floating point numbers over here are nice and aligned on the right-hand side. And if we also set this to 2 decimal places, it'll look even better. I intentionally didn't do that at first so that we could see what happened. It's not a requirement to set the number of decimal places. But look at those numbers. Even the decimal place lines up nicely. If you were going to try and make a formatted output, that's going to be really useful by being able to set that field width. Okay, so there is a way you can force something into being an integer, and that's just going to be a d instead. So, for example, we could grab one of our prints here as well. Let's just grab this top one and put that down here, and we could force this to be a d and see what happens. And you'll notice it's going to complain because it doesn't know d for an object of type float, right? Because we haven't converted it. So we would have to manually convert this to an integer, and then we could use some of these same like width size. Whoops, the 20's got to go first. There we go. Um, now you can see it's now the integer, but we're lined up the same. So you've got the same. You don't obviously have decimal places, but you have the same things. We could also put in another one, same thing with the thousand separator, and that'll work just as well. Now, last but not least, you'll notice there's this big discount up here. I put this in just because it's a quick hitter. If you want to multiply something, let's say we always wanted to multiply our calculation. Let's grab one of our lines up here. And we always want to multiply it by a constant value. It's frequently good to create what's called a constant. It's just a variable that's generally in all caps that we can use to multiply things by, as opposed to using what we call string literals. Um, and you'll see it's just going to multiply it by that discount, and it's going to get us a number. So it's no different than multiplying by 0.9. It just helps you a little bit sometimes with seeing exactly what that value represents. Okay, so we'll stop there. Last up for this chapter is turtle graphics. So we're going to end with some drawing.